This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 2, The Discovery of Atomic Structure. I'd like to remind you that most of this will be review from Chem 1. The objective for this section is to understand the experiments that led to the discovery of electrons and the nuclear model. Get it? Helium, helium. Hopefully you got that. I also want to remind you that you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So we want to remember that particles with the same charge repel each other, and particles of different charges will be attracted to each other. So have you ever wondered why electrons, which are negatively charged, they don't crash into the nucleus, which is positively charged, because that's where the protons are? So what's occurring? What's letting the electrons be in their energy levels and not just crash into the nucleus, which they should be attracted to because of the charges? Well, they keep moving. These electrons are constantly moving. So if we think about the Earth and the Sun, again, gravity is going to pull these two bodies together. But Earth, because it's moving in its orbit and on its axis, right, it's moving two different ways, it can keep from falling toward the Sun but never actually fall into it. So electrons are very similar to that. They're constantly moving around the nucleus, even though there's attraction to each other, same way that the Earth is attracted to the Sun because of gravity, but they never crash into each other. They stay in its orbit because of the motion. So we need to understand the three main particles of an atom: electron, proton, neutrons, what their charges are, and where they can be found in the atom. So let's talk about J.J. Thomson and the cathode rays and his discovery of the electrons. So we want to remember that cathode rays are just radiation, and I'm going to show you an example in a moment. He discovered the electron, and he calculated the electron's electrical charge to mass ratio to be this 1.76 times 10 to the 8th coulombs per gram. And a coulomb is just the SI unit for electrical charge. And we're going to actually get into more detail about coulombs later on in the course. So here's his experiment. This is the cathode ray tube. And we're going to see that he's going to form cathode rays or radiation through the tube by connecting these electrode, the positive and negative electrode, to, let's say, a current, a voltmeter, or let's say a battery. So this is kind of like a battery. So what happens is he ran the electrical current through the vacuum tube. So what do you think happened to these rays? So it started out with the negative charge. You turned it on, negative charge, and it starts going. What do you think is going to happen to it? Well, by passing this current, the beam appeared to move from the negative end to the positive end. So that's basically what he saw, negative to positive, and that's what he assumed, right? What happened? He probably came up with a hypothesis that said, yeah, since negative and positive attract each other, I'm going to put a current through this, I'm going to see these particles, and they're going to be attracted to each other. So now he added an electric field to the tube, top and bottom. Now remember, this is still negative and this is still positive, but he also added the positive here and the negative here. So what do you think is going to happen to this current of cathode rays, or this radiation? Thomson discovered that these moving pieces must have been electrical, or I should say have a negative charge, because now they're attracted to the positive field that he put on this cathode ray. So that's how he discovered this, these electrons. So remember that in the very beginning, the first guy said that the atom was just basically a sphere, but he came up with, I like to call it the chocolate chip cookie model, because these chocolate chips would represent all these electrons all over the atom. Then Mr. Millikan, he came up with what was called the oil drop experiment. So he actually measured the charge of the electron by calculating the mass of the electron. So now remember, this was from J.J. Thomson's coulombs per gram mass to charge ratio. And if we have the charge of an electron, then we can discover the mass of an electron. And notice it's very small, negative 28, very, very small. So how did this happen? Well, here's the experiment. There's our oil, there's our what's called atomizer, there's the microscope so we can see what's going on. He basically squeezed some atoms in there, okay? And what happened is these oil drops, what happened to them? Well, again, what did we see? We saw some x-rays to give the drops a charge, okay? So we had to, these were just oil drops, but we had to give them a charge. And what happened was, it became positively charged. So we have these so we put a charge on the plates. So we have a negative and a positive charge on the plates. So some drops would actually hover. Okay, so they just kind of stay in the middle there. And then he measured the drop and found the volume, and then he used the density formula, rearranged it to do mass equals density times volume. So from the mass of the drop and the charge on the plates, he could actually calculate the charge on the electron. Pretty interesting. So what is radioactivity? Basically, when they discovered uranium, they discovered radioactivity because it's the spontaneity of the radiation and its emissions that it gives out. So there are 3 types of radiation: alpha, beta, and gamma. Just read over that information. Don't go crazy. This isn't going to be that pertinent on the exam. So then we come up with a nuclear model of the atom. Rutherford came up with the idea that atoms are mostly empty space, and he also discovered the nucleus. Again, how did he do this? Well, it's called the gold foil experiment. So we have lead, we have some uranium. Again, that's going to be our radiation. He took a piece of gold foil. Okay, so think about your aluminum foil, but pretend it's gold. And then he has this fluorescent screen around it. So what he did was he shot these alpha particles through the sheet. He wanted to see what was going to happen. So this is what he expected. He expected all of them to go through, okay? So this is what his hypothesis was because of Thomson's plum pudding model, or like I said, the chocolate chip cookie model. According to his model, he thought that they were all going to go through, right? There's so much empty space and there all these particles are going to go straight through. So how about if we have a lot of gold atoms again? Lots of space, so all of that radiation is going to go straight through that gold foil. But this is what he actually saw. So what is going on? So his conclusion, his one conclusion that the atom is mostly empty space and the radiation goes through those atoms was correct. But then something here happened. They would hit something or reflect on something, and that's why he called that the nucleus. So here's our alpha particles. Again, most of them go through. Some get reflected to slightly, and some get reflected like they hit something really, really hard and bounced back. Okay, so I'm hoping that you have questions for me later on in class.